गुड इव्हनिंग एव्हरीबडी. आपण जस्ट 1 मिनिट फक्त थांबूया. वी विल स्टार्ट बाय 9 o'clock. Yes. So, good evening everybody. And this is our 8th meet of Statistical Saturday Club. I hope you guys can remember that last week we have started our another track of statistics. So basically we are dealing with data. First we started with Excel to get some toolbox in our toolkit so that we can dig the data and understand it with the tool of Excel. So that we have preferred that we will start with Excel. So we have finished in first 6 sessions. We finished the Excel part, and then from last session, from 7th session onwards, we have been moved into the statistics part. So actually, the statistics is the core. You can use Excel, you can use the SQL, you can use the Python. That doesn't matter, or even you can use your pencil and notebook. The majorly skill and understanding you should have is the statistics. Once you know that, once we have grabbed good hands on the statistics, any toolbox will be okay for that. So now, like last session we have started that, we will go practical utilization of the statistical concepts. We will not give major focus on the theory part, because in and out, or in your school education, college education, some of you might have come across the statistical concepts. So we will not be interested in revisiting that concept. Just we are now looking forward that how we can implement that in our real life work, especially the development sector work. Okay, so the agenda today is very simple, and this is about the understanding the data. So whatever the data we have got, we need to understand the data thoroughly, and for that there are some measures are called, like the measures of central tendency, the measures of dispersion, and the measures of position. So actually this is not anything special, just this is the grammar of statistics, and so we are using those words here. But we will start looking at how in practical we can see the data, and we will start where we have left in the last session. Just give me a second to open our data set. Okay, I hope now my screen is visible. I will just zoom it bit. That. Okay, so I have just zoomed in. So this is our the data which we have looked in the last session also. This is the actually real-time data we have collected from one of the slum in Pune for one of our project in solid waste management, and this has been collected recently, last 2-3 months back. So the basic data, last time I have introduced to all of you, but again I will introduce it. Like it has, uh, last time we have said one principle. Again I will just, for the reinforcements, I will just repeat it again, that whenever we are organizing a data, whenever we are storing data, whenever we are entering data into the Excel part, we need to keep in mind that the each row, here I have selected the second row, the each row should be the record of object. So you can have, now here it is the whole information in one row about a family. See, I'm not integrating any other part or any other object in it. I am not mingling the object of family member and the family, or car and the family. This is the only one row, it's dedicated to the family, one family. So in row number third, it is another family. In row number fourth, it is another family. And this is the whole data about the families. You may collect data related to the persons also, but we learned that it is better to store it in the different sheets and then connect it with the survey ID. So here I have given the survey ID. it is very important practice that the each row you should give a unique ID to identify that row uniquely. So here, like I have given the survey ID, you can give, suppose it is the data of student, you can give the roll number. It is data about the individual, then your either your mobile number or your Aadhaar card number can be the primary key. So that key you can set up. That doesn't matter, but it is the good practice that each row should have a key. Now here I am having this one row for one family, and I have collected the data from the other families. Now the each column must be the attribute. So it's like you are taking one row as one object, and then you are talking about each feature of that object. Like here, I'm having family. What I'm having the object is that Google code, so that where that family is residing. What is the lane number of that family within the slum? Who is the head of the family? What is the mobile number of the head of the family? Is that family WhatsApp or not? How many family members are there? Is there any monthly income? How much? Where the waste they are giving? Are they giving it to the waste picker, or they are disposing somewhere out? Uh, do they have the separate bins for dry and wet waste? Do they give monthly user fee to the waste picker or not? And what is the user fee amount? So this is about our whole data, and this is our data set. And if you remember, last in the last session, what we had did is that we have categorized this data set into the qualitative and quantitative data. And then within the qualitative data set, we have seen the nominal and ordinal type of data. And then within the quantitative data, we have seen the discrete and continuous data. Here, the number of family members is the discrete data set. Whereas if we are measuring something, suppose here it is the height of the head of the family, then it might be the continuous data. Here, wherever the data like primary education, secondary education, if we are taking such a data, then it is ordinal data. If it doesn't have, like here, name of the family, head of the family, there is no any sequence here. It is just qualitative data. We can take it as a nominal qualitative data. That exercise we did in the last session. So now coming, if we have finished that and we know now that the family members is our quantitative data set, quantitative data variable. So we have seen these are some of our variable, and monthly income. This is my again quantitative variable. Some of here the WhatsApp available is my qualitative variable, and we have seen in last session also that with the coding we can convert it to the numerical, that we will see the later also. Just one thing before we really go into our today's session. If you see the headings of my all columns, you can see that I have not used the space anywhere. It is the good practice if you are going to use the softwares such as SPSS, or if you are going to use the SQL, if you are going to use Stata or SAP. It is best practice that you give the only one word name to the your variables. So in that case, it requires that, like mobile number, I cannot give only mobile or only number. I need to give that mobile number because I might have the other number also. In that case, what I am using as my strategy, that I am using the underscores instead of the space. So I'm not using the space like this. This is two-word heading. I'm using the underscore. If you are comfortable, many people will use the capitalizing the each for starting letter. So that mobile number, so that M they will capitalize and N also capitalize. It's depend on your practice, your convenience. But I prefer that I should have the underscores because it makes it more readable. So this is the one of the tip I want to give all of you to cleanly organize your data, because if you want to again transport this data to spaces, now I have collected data in Excel and I want to do some advanced statistical analysis, I need to go with Excel spaces. The variables which are in multiple words will not be accepted by the such a softwares. Okay, so now as last time also we will just go into the discussion that now we want to understand this data little in depth. So how we can start about it, what are the things I should know. We will take only one variable now, and that is we can take as a monthly income. Okay, because that is the one of the prominent variable when we are studying the socioeconomic status of the persons. So we will take only one variable. I want to understand the monthly income variable in depth. I want to know some better understanding about this data which I have collected. What are the things I can explore to know, to get idea about the whole population? What are the things I can know in addition to the random? Any ideas? Please share. Initially we have seen that all the we were checking the data, and we have seen that which data is quantitative, which data is qualitative. That exercise we have completed in terms of understanding our data. In the giving into going into the next step, what are the things we can do to understand this data, especially we are now taking to the one variable, that is a quantitative variable, monthly income. What are the things we can do?
We can get average of monthly income.
Yes.
Then we can get maximum income, minimum
Yes.
income, then range of it.
Yes. So that actually suggested that we can have the average to understand that what is actually the spread over there. And while I was studying for this session, some going into some material over there, I got one good analogy. You can also remember that the data, whenever you are taking any variable, imagine it as a city. You are going into the new city. So, what are the things you will do first if you want to stay in any city? Which location is the best location to stay in any city?
The mostly the necessary amenities which near to that place.
Yes,
So probably we'll select that location.
yes. So probably where the all the amenities are there available, like bus station is near, railway station is near, and if you see very thoroughly that many of the cases the center of the city is that the location where you will get all the amenities available, right? So that is the best place to stay whenever you are going in new city. Suppose I want to explore the England, so I went to the London and I want to explore London city, then I will prefer to stay in the center of the city so that I can access all the points at a nearest places. So that once you identified what is the center of that city, then you can look at that how much far the other locations are, whether it is 8 kilometer or 9 kilometer, 10 kilometers, and then we can see that what is the position of that whole points, or the points which you want to explore. In London I want to explore British Museum Library, then how far it is from the center, so that I can arrange my data. The same case which Akshay was saying, that what is the range of that city, how much wide it is, whether it is has the diameter of 20 kilometers or 30 kilometers, or it is just 5 kilometers, small city. That in that case you will get the general idea that how much, what is the spread of that random variable. The second, he was also said that the average is nothing, very basic concept. If you take whatever amount the every people have, I will take back all that amount, then I will count how many people are there and I will distribute them equally to check that what is the person each person can get if I accumulate this. And if you have studied the economics, we are using this concept very often to compare the countries. Can you recall what is that concept? We are using in economics to compare the growth of the various countries, and we are doing the same thing which now Akshay has said. We are taking the average.
GDP?
Yes, Sajal, it was not clear.
Yes, GDP.
Yes. So it is per capita GDP. What we will do, we will say that what is the income of whole country, and they will divide it by the number of people residing inside the country, so that we will get one figure, which is called as the per capita GDP, and then we can compare that with the other country. So that is, this is the real practical implication of the mean or the average which has been shared by the Akshay. Any other thing? Okay, so now I'll just demonstrate that how we can do many of these things with the Excel. So now Akshay has suggested rightly that I will just add one column here for our demonstration, and maybe I can add two columns. Okay, and I'm using the Google Sheets. Whatever software you want, you can go with that, and I can calculate the minimum and maximum. Also, I can calculate the average, correct? So that once, how to calculate the minimum, it is the min formula uh, which will give us the minimum. So now here we can see that the minimum is 1000, and the inverse of it like max, and here the Google Sheet is auto suggesting me, so actually I got the range again, and maximum is 90,000. So there is big gap. We can see that from going from minimum is 1000 to maximum is 90,000. So spread is of almost 89,000. Spread is there. So if I plot it on the my graph, my x-axis is going to be, I think, very wide in terms of there. How to calculate average? We are having the formula average. Again, I will select these two. These all things we have demonstrated in the Excel tutorials. That's why I'm not wasting much time. So here we can see that the spread is from 1000 to 90,000, but average is somewhere around 17,000 only. Okay, by understanding only these three numbers, what you can infer?
Maybe low monthly income people are more.
Yes. So see that how this, without seeing to whole, that we are having some around 200 families data, we can just with only three numbers we can infer something. So that rightly Aditya had said that, because see the range is from 1000 to 90,000, but if we take the average is coming only to the 17,000, around 17, 18,000. That means that those who have very less income, the number of people is more. So those who are having the low income family, the count is more. Yes, right. So this is also called as for the skewness, that we will see the later. But any other measure can we check with in this case? Mean and max is called range. It's good measure to see that what is the spread of the data, and then average we have seen. Any other thing which you can just intuitively you think that we need to do?
We can categorize in grade, like in company we are giving A grade, B grade, like this.
Yes, but then we will go into the data analysis part, so that we will start some modification of the data, then we are going, just I want to know about the data. See, just interestingly, many a case, I'll just start. The plotting that data itself will give us very good understanding about that data set. Okay, many a times, whenever it is possible, just you try to make, whenever you get one data set, plot the graph. So now we will try doing that. We have not explored this part in the our Excel tutorials, because that is somewhat we have thought that we will explore in our coming days. So I have selected the whole range including the header, and then I'll go in insert in charts. Same thing you can do in the Microsoft Excel also. Okay, and then I will change the chart type to the line. Okay, so now the chart is visible.
Yes.
So
Yes.
now you can see that almost your all population is from 0 to 50,000. Correct. If we see that from 0 to 50,000, this chunk is all people are in between 0 to 50,000, and there are only two people, which here is 60,000 and here is 90,000, which is more than the our whatever the range it is there. So now this graphically it's a good representation to see that how our data is behaving. And so rightly, as suggested by the Aditi, if you check that below 25,000 there are more number of points are there. Even we try to change this to the this is okay. So now we have pointed it as a points. So now we can see that below 25,000 there is large amount of dots are there. Then 25,000 to 50,000 there is less number of amount, and more than 50,000 there are only, I think, two families are having monthly income of 60,000 and one is 90,000. Uh, can you anybody can say this is this point has one unique word in statistics? Anyone knows
It's
this?
mode.
Huh?
Mode. Mode. Are you talking about mode?
No. Mode is the data point which has more frequency. Suppose 1000 is repeating for 5 times, then another all values 2000, 3000 are repeating one or two times, then 1000 is my mode. Mode is the value which is occurring more number of times. This is the value. And what I want to say that my whole graph is here, all people are living here, the only one person is there who is living somewhere outside on the outskirts. Okay, so it is called as outliers. Okay, outliers are the data points which are unusual. So many a times if you take measuring the height, all people will be from 4 feet to 5 feet, 4 feet to 5 feet. Suddenly one person will be there who is 7.5 feet. Okay, and we will see that how these data points will adversely affect our data set. Okay, so this is the good idea that you can plot the data points, and I will share one concise note. I will not go much into the visualization part, but I will just share the one brief rules of thumbs, that if the data type is of numerical, which type of graph you can plot. If you want to see two variables, which type of graph you can use. And this is just a rule of thumb. It is morely intuitive. Like if you want to cover about 100%, then you can make use of pie chart. Suppose if we categorize these all parts, like this is 25,000 A category, B category, C category, and all will be adding up 100%, then it's better you uh, showcase it with your pie chart like that. So that I will share so that you can make use of that. But I want to just uh, say here that even the plotting the data initial stage, might give you good understanding about that data set. Okay. So now the third part is, you might have heard the Akshay which he shared, that is the mode. So what is the mode? I'll just make here one. I will say that here is the type of mode. So 1, 1, 1, 2, 3, 4, 5, 4, 5. In this data set, my mode is 1. Are you getting my point? Why? Because 1 has been repeated for 3 times, 2 has repeated for only 1 time, 3 1 time, 4 1 time, 5 1 time, but 1 has repeated for 3 times, so it is my mode. So we will try to calculate the mode also for our this data set is equal to, here simply the mode is there, and if you check here, it is saying that most commonly occurring value in the data set. Okay, and now you can see that 15,000 is my mode of the data set. So 15,000 is the value which is occurring more number of times. And also you might have heard about the median. Have you heard about the median? If I'm having the data set,
Yes, yes.
yes, so if I'm having the data set such like this, uh, can you share that what will be my median? I'm having this variable called x, something x variable is there, and it is taking 3 values, 24, 2 and 7. What is the median of that with random variable? Okay, so how to
I
calculate
think
median?
7 is the median.
Huh?
7 is median.
Yes, correct. So that Pranada shared correctly that 7 is the median. And why? Because we usually how we'll calculate this median is, just we will take this data set and we will arrange it either by ascending or descending order. And median value, which is in this case we are having 3. So what is the our median value? It is 3.
7.
Second one.
3 divided by 2. Okay, so it's around 1.5, so that this is more than 1 and less than 1. So that we usually do this, right? We'll take here, if you remember that I told you that we are having something called mod function, correct? Which will take the only the modulo value, and again there is one something called reminder. So here we can use the mod of 3 and 2. Sorry, this is quotient. 3 and 2, and then we will add it to the 1. Okay, so that we are dividing by 2, and whatever the remind, we will not thinking about the reminder, and we are adding it the one part if it is in odd number, so that you don't worry about how to calculate the median much more, because now we can go and just calculate the median. More importantly, why the median is important, that part, and we will come to that later. So now here you simply you can calculate the median again there is formula, you need not to worry about how to calculate that and all the steps, and we are not purposefully focusing much on that. And if you see, even here the median also the 50,000. Now you see our range is from 1,000 to 90,000, but our average, mode and median are saying you that these are called the measures of central tendency, where the center of your data. So more data has been concentrated on these values which are around 15,000 to 17,000. So that here the data set has been concentrated in the case. So now when I need to use the average, when I need to use mode, and when I need to use the median in my practical life. So I'll just give you the rule of thumb. When it is quantitative data, you can make use of the average. Okay, quantitative data is monthly income, family members, then we are having the user fee amount. These are my quantitative data I can use. The mode is mostly used for the qualitative data sets, because here you can have yes and no WhatsApp. In that case you can use the mode. So now here I want that we'll just demonstrate mode for WhatsApp. So I will just take mode WhatsApp. Here we will select. Okay, okay, so now here the mode is not supporting for the uh, text data type. In that case simply what we can do is that we will select that data and insert into our chart. And here we can see that almost both are having yes. So here I am having the count. Just add our data label. So now here almost 451 times people families are having the WhatsApp, and only 11 families are saying that they are not using the WhatsApp. In that case the 451, the value which is occurring more number of times, is our mode. Okay, so in that case for the qualitative data we can use the mode. What is the use of median? So now it is very interesting. I just want to demonstrate you that here is the values. I'm just ordering it asymptotically. This is my again variable y, which is taking some random values. I will calculate the average for this. Okay, so my average is around 3.5. Okay, then I will calculate my median. Now you can see that my median is also 3.5. Are you able to see that? My mean and median both are 3.5 for this data set. Okay. Now I just want to add one more data point here, and which is 100. Again I will recalculate this by adding this, extending my range to E9. So now because of adding this another value, which is, I said that you like outlier. Outlier is the something which is outside. Someone is sitting outside some distance part. These all people are playing within 1 to 10, 1 to 6, and this one single person is having 100. So that is outlier. So because of adding this outlier, the average has been changed from 3.5 to 17, which is almost 5 times extra. Okay, now I will check with median what happens with median. Now it has been changed from 3.5 to only 4. It has changed from 3.5 to 4. So even if your data sets are having outliers, it will not give. So what it is saying that your central tendency is 17 points. So it is, suppose it is marks. So on an average, people are getting 17 marks. If I don't know the y variable, if suppose there are 1,000 values are there, I might suppose that, oh, so many of the students getting the mark 17 marks. In that case, we have seen about the income, as Aditi explained us that many of the people might have the income between that range, and it was true. So here, because of outlier, our mean will give some different value to us to understanding, and that's why it is better to use the median. Is it clear that when to use the median and when to use the mean?
Yes, Bhaiya.
Okay. So now we will come to the specific our utilization or the use of these ideas while comparing the two data types. And now we will see that what kind of analysis we can do with this data set. Before, I will just fill out this some numbers here so that I can complete this data set. Okay. Okay, so we will start with this one small example. Here I have division X math scores. Only 5 students are there, and there is again I have division Y math scores, which is here. I hope that it is visible.
Yes, yes, we do.
Yes, Bhaiya.
Yes. Okay. So now I'm interested that which division is performing better. Correct? How can I tell that? Which division might be Praveen Dada feel this example interesting, that I want to now compare these two divisions. I want to check the performance. I am teaching to this both divisions and how these divisions are performing. So how can I use this whatever knowledge so far we have used in our practical example, how to do that? So mainly many a times what we will do, we will take the average of this whole all the students I will take, and I will check that on an average how these two divisions or students are performing. But to be precise, now if you see or check that this both of the divisions are having the same mean, correct? Now I will try that. Okay, let it be, I will check the median, and if you check the median again, it is having the bapre, so it is having the same median and same mean. And because these all values are not repeating, it doesn't have any uh, mode, because there is no value which is occurring more than once, correct? So that how can I compare? Is that mean that these two divisions are performing exactly same? There is one another measure which Akshay had suggested. It was the range, and in that case, I think some differences will come. I'll just do it. This is in one shot, means in one. Okay. So now I have did the maximum minus the minimum, and now it is giving me 40. So it has the range of 40. What happens? We will when do the, okay. So now here the differences are coming. That the range part is something different. Correct. So my maths student, because I will just let's make it in another colors. should be better visible. Okay, so now my X division is having less range and my Y division is having wider spread. Does that mean that one division is performing better than other, or how can I do that? Okay, so in that case, the better to get the better idea, we have some more measures, and it's called the measures of dispersion. Okay, so now what is the measures of dispersion? See, if it is mean is coming same, what the people have said that okay, that is fine, that mean is okay, all values are concentrated towards 40, but what is the spread, what is the variability from the mean? Suppose my mean is 17,000 in last our example, my spread will be up to 90,000, which is too much. In the case of our social sector, we know that the inequality should be less, so that spread should be the less. We want how we can minimize that spread, but to change that how much spread is there, there are two very prominent measures are there. One is called the variance, okay, and another is called the standard deviation. Have you heard of this?
Yes, sir.
So those who have heard this, can you tell me that what is the relation between the variance and standard deviation? They are just like twin brothers, or brother and sister, or two brothers or two
Square
sisters.
root.
Ah, yes. So actually, the standard
Square
deviation is
root.
nothing, but it is actually the variance, but it is taken as the square root of the variance. And why we need that also, I will just demonstrate. I hope that we are having the time here. So okay, so we are having 15 minutes. So how to calculate the variance? So people come up with idea that okay, let me have first average. Okay, average is my 40. I know that. So I will just take that value in our H1 cell as a 40, because I want to demonstrate our first lesson of the Excel, why I taught you that we want absolute cell reference, relative cell reference, this theory part. And now what I want to do, I want to check that the distance between this mean and this value, all the values, how much difference is there. Okay, so I will check that is equal to, I will take this H1 cell, which is my mean, correct, minus G2. Okay, so almost zero difference, correct, because mean is 40 and my first student is have 40 marks, so difference is zero. In the case of, again, in the case here I want H1 minus the H3, so this is again 30. And what is the case is happening here, I want H1 to be fixed and G2 G3 to be changed. So I want these values to be changed, but these values to be fixed, and that's why we will use the dollar symbol before we drag this. So I will fix the H1 part in both of my formulas, and now I will just simply drag it below. Now you check here what is happening. Here are some negative values are coming, correct, and if I sum this all the values, I will again get 0. So that what does that mean? My variance will be 0. Is that is the case? What I am doing wrong? Any idea? Anyone? See, here it is coming minus 30. Actually, I don't want that. Right now, I want the difference, how much it is deviating. If I take minus plus, that will not give me the right way. I want whether it is plus or minus, it is 30 units away from my mean, whether it is positive side or negative side, right? In that case, what we can do, we are having one formula which I think we are not seen before, and that is called the absolute value of the function, ABS. Okay. So now what absolute function will do? Absolute function will take the only, they will just cancel out the signs. It will not keep the negative sign. It will just make everything as a positive. So 2 and 4 is having distance of 2. 4 and 6 is also having the difference of 2. So that this my function will return only the 2. So I will just drop it below. And now you can check that I am having the all positive values. So I will just sum all these values. And I am having the summation as a 80. But this is not my variance. What is the variance? Variance is actually the average between these distances. Okay. And what will be the average distance? Divided by 1, 2, 3, 4, 5. 16. Actually, what we have did to take, am I going into the speed? Are you able to understand what I am doing?
Yes, yes.
Yes. So actually, I want to check that how much the each value has been variable from the my mean. Okay. So now here what I have did that I have taken the absolute values, but that was not the case. I don't know why statisticians were like that. So what they did, if you take as mathematics, we know that the 2 square is equal to the 4. And what is the square of minus 2?
4. 4.
4. Negative into negative comes to the positive. So they used this method to calculate the variance. So what they have did, they said that you need not to use this absolute function. You need not to make it positive by itself. Let it be as it is. What we will do, we will take the square of that value. Okay. So I will do h2 divided by h2, that is square. Okay. So now all positive values came. Are you getting my point? All values are
Yes.
positive. So now when I will take the average, so now that will become my variance. And this is the variance in terms of square meter. Suppose if I am measuring this in meters, this is not score, but this is the running distance. What I will measure this as meters. So all will have the unit as a meter. So what will be the unit of this? Is the variance calc. What will be the unit of this variance? Can you guess? Because I am squaring it, it will be meter square meter. It is not giving me the exact value. It is giving me the square meter because I am doing this multiplication part. But when I want, the people said that I don't want the variance or the difference in meter square, because I am measuring values in meter. Papa, you are doing it meter square. It is not correct. I want it into the meter. So that they said that okay, then you can take the square root of this value. So for that we are having the function called SQRT, square root. So now we can check that the variance here is the 20. It's the standard deviation is here is 20. Are you getting my point? What we are doing
Yes.
and
Yes.
how we are doing and why we are doing this. If you have any idea, any doubts or any clarification, you please get clear here, because if you check the whole probability theory, whole your statistics, you will be going to calculate the variance and mean and the standard deviation, and you will do whole calculations based on your standard deviation only. So in that case, it is very important that you calculate how to do this part. What are the concepts here? Get clarified now. Are you having any doubt over here?
Mayur, can I ask something?
Yes.
Yeah, so actually, when you calculate the average, just check, take this example of scores. When I get average of 40, then I can say that my classroom mastery would be 40, right? Average
Yes.
mastery would be 40. That I can understand. But when I calculate the variance of these marks, so what it denotes, with what if I want to reflect on this variance, so what would be use of that variance?
Yes. So when now like teacher, I want that all students should perform well. It is okay that on an average my students are having 40, but if all the students are in the range between suppose 35 to 45, one case, in that case also you will get the average of 40. Another case is that I am having the variance from 10 to 90, but again I will get the mean of 40. Are you getting my point? So range will be much larger. In that case, some of my students are actually scoring very poor, and some of my students are scoring fabulous. They are having more than 90 marks. In these two classes will not be the same. That's what I want to know with the standard deviation. If standard deviation is 20, that implies me that there is much wider gap in between the top students and the lower students. There is much gap. It is not like all the students are on mean or average. So I need to identify that why some students are scoring very less marks and why some students are scoring more marks. Is there is a need of some giving some different methodologies for them. So this is the practical use of the standard deviation. Okay.
Yeah, so I understand. Just correct me if I'm wrong. So
Yes.
this standard deviation or variance will help me to understand the exact learning gap in my classroom in terms of score.
Yes, so if you take this typical example of the scores, then it will show me the gap between the uh, high performing student and low performing student. If that is more, I need to take more care. If it is very less, standard deviation can be zero. If all your students are have scored the 40 marks, then your standard deviation will be zero, right? Because here all values will come zero. All 40 means all values will come zero. So in that case, I need not to worry much because it is on the mean, and I need to only worry about that how can I increase this average. But the standard deviation is 20. That does imply that on any side, other sides, the students are having much larger marks, much smaller marks, much lesser marks, and much greater marks. In that case, I need to check. In particular, this is the case. In general, any variable if you take like income, if you take the height, in that case, it will give me the idea of the spread in one unit. The range is having also one unit, but if you check that the range, now I will just demonstrate you the range in the case of the income, it's 1000 to 90,000. Mean is around 17,000, but the standard deviation will not be that too much high, up to 80,000, because only one value is there which is above. So that doesn't I'm not caring much for that one value. Am I right? Also, is it clear up to here?
Yeah, I understood.
I hope that other people also, those who are there. The one more thing I just want to tell you that if you check our the DP of our group, Statistical Saturday Club, actually that is the curve of normal distribution. We will come later that, but this value can help us to identify, to tell me that whether data set is uh, outlier or not. Okay, so I said that now here if you come, that I said that last time that 90,000 rupees here in our case of monthly income, here we said that 90,000 is our outlier based on some graph, right? But how statistically you can say that, how you can like say that with some statistical method without going or looking at the graph. If I give you the data random variable, and if I ask you that whether this value is outlier or not, in that case we are using the standard deviation for our purpose. So standard deviation is having so many other implications which we'll learn later. Are you okay with this?
Yes, yes.
Okay, so that we will just now check here. One more thing is that I will not check into the variance, we will just simply go into the standard deviation. Now here we will check the standard deviation. It has a formula STD dev, standard deviation of this value, and now it is coming only 8652. If you check that, the real spread is not of 80,000 which I am looking at here. So that's why I am having range and standard deviation different. If you check range here, it is around 80,000. So I might say that, oh, there is too much gap, there is too much inequality, too much everything is there. That is not the case. The inequality is there, but just pardon me, सेशन मध्ये आहे तुला कॉल करतो. ओके ठीक आहे. Okay, so sorry. So the standard deviation is telling me that the spread is only from 8,600 rupees. That much difference is there within the average, and that's what we have seen in the graph also, that only one value is on the upper side of the bound and there is no. But what if the standard deviation is go up to the 10,000 rupees? That means up to the 20,000 rupees of gap it is there, because it's 8,000 means 16,000 of gap is there. So these numbers are again we need to take relatively also, and we will just check the implications of this. Now again I have taken some randomly generated these numbers of division A English score and division B English score, and I want to just compare these two groups. So I will just check with average, because these all are numerical values. So my average is around 62.8, and again average for my. So yes, so first division, A division is having very less average, and the second division is comparatively performing better. But is this the case in terms of standard deviation? I will just check that it has only the standard deviation of 19 marks. Around 19 marks it is varying. Now I will just check with this same thing, standard deviation in terms of this, and it has only 6 marks deviation. So now you can see that I can say that the division B is performing, so there is no doubt, I cannot doubt it. There is no biases involved. I don't know students from division A, division B, but statistically I can say without any bias that division B is performing better than the division A, because it has a higher average and also very less standard deviation. Less standard deviation is means that all the marks are around 81. So 87 to the lot of number are falling between this 87 to 74, that range. So many students are on the higher part of this division, So in this way, now I have just demonstrated you the only one example of standard deviation. We have learned some two, three formulas like mean, mode, median, and here we can see many concepts we have uh, learned like mean, mode, average, median, standard deviation, and the variance part. So here we will cover with these three parts like mean, mode, and median will give you what is the center of that data, what is the center is there, and the part of variance and standard deviation will give you the measures of dispersion, how much that data has been spread across the data set. Is everyone is clear with this?
Yes, Priya.
Okay,
Yes.
anyone having any doubt?
Actually, I have doubt.
Yes.
You said that less standard deviation is like while we comparing any two variables, if something is less, like standard deviation is less, then we can say that's better result for
No,
that
no,
case.
not I'm not
But
saying this bit.
is it true? Is it true for only marks related data, or like if it is more for other variables, it will be good?
See,
Are there any cases like
this is what
this?
I'm saying. I'm not saying the good or bad. In particular, with marks data, the standard deviation is less. It is good. Why? Because uh, we want all the marks to be in one set. All the students should be having. Suppose the students are having all students are having marks between 80 to 85, and another class students are having marks from, some students are having 10, some students have failed, some students are 35, some students are 60, and some students are scoring more than 95. So that is not the good class, correct? That's why I said that good or bad. In general, the standard deviation will give you the spread. In some cases, like I will take the example of medicines. You are checking that whether this medicine is useful or not, and how many percent you are calculating percentage. What do you want? You want standard deviation to be more or standard deviation to be very, very, very less? What is the case?
Can you repeat the question?
I'm testing one medicine. I have created one pill which is now treating the fever, and I'm giving that pill to 100 student my patients, and I'm checking that how that pill is performing, and I'm taking that in percentage. Suppose the totally fever gone 100%, I'm taking that their tests from 0 to 100%. Okay, you got my answer. If I am a patient, I got my newly invented fever pill, and if my fever gone, I will give 100%. If nothing change, I will give 0%. If something change, I will check with thermometer whether fever is less down. I will take 10%, 20%, 30%, 40%. I checked it on the 100 patients. Now I'm calculating standard deviation. That standard deviation, what I will be intended. I want very less standard deviation or more standard deviation.
Just one question, one additional question. So, that calculation, that use of standard deviation will when means if you are comparing two variables, that time we can use the standard deviation, right? Yes. For
No, no.
example, in this example, you are comparing two classes,
Yes.
right? So you are comparing two classes, same, and it's depend on means just if you want to qualify whether that value is good or value is bad. So I feel that it's depend on the type of that data. For example, say in this case, we can say that that value is good, the for the score. But it's if same data is about two jails, and the number of crime committed by a particular person is there, then we can say that more deviation can be a good, right? So it is depend upon the type of data. And you give example of that testing in newly invented pills, but I feel that if there are two medicines to two different groups, then we can compare with the standard deviation. I'm
See,
not sure whether my response is right or not, but
no, in case because I have introduced the standard deviation that way, you please don't take in that way. That is comparison only. You can compare. Suppose I have invented two pills. For 100 people, I have given one pill, and 100 people I have given second pill. What I'm saying that what is your spread from the mean? So now, in case of, I want the heterogeneity, where you said that in jail case or somewhere some, I want that many people should have very less amount, very people should have more amount. In case of lottery, I want this heterogeneity. If I'm designing the lottery, I want more standard deviation, because if there are some many people are in less side and some people are in upper side, then only I will gain the income. So the standard deviation you think about is that the spread of the data. You check the spread of the data. You are plotting that on your x-axis and y-axis. What is the spread? What is the range? Range and the standard deviation are going in the same way. Why you calculate the range? Because what is the minimum and what is the maximum? So I will get that, okay, the all values are falling between these. So now what I'm saying that I want to check this, what is the spread from the mean and not from minimum and maximum. From mean, how much deviation is there? So deviation, the word itself we are using now, that how much deviation is there? It is very less deviation or very too much deviation? Too much deviation I want in some cases I want very less deviation. So purposefully I have given the medicine use. In that case, you cannot say that okay, 99 people I am having very good response, one person said 0% response, or two people said with very zero, I have not got any effect. In that case, it is not a good medicine, because it is responding to different people differently. You are having the average as 99% and standard deviation of 1%. That does mean that you are having very very close, and the features, different features of different people are not affecting that much on your pill is you are responding properly. So don't only take comparison, you can understand one variable also. I can collect only one variable in data. I'm only going and collecting the height of the students. So I only data. I'm not having any other data, any other group, anything. In that case also, suppose it is in Anganwadi I am taking, I want the standard deviation to be less, because all the students should grow monotonously. Uh, One student is having height of 2 feet and 2 inch, and another student is having 3 feet and 5 inch. So in that case, I don't want such case. I want, suppose it is 3 feet on average, I want some people to be 2.8 or 2.11, and some people to be 3.1 or 3.5, like that cases. So I want, whether I want this data to be spread on some part, or I want data to be spread on multiple. That is the measure for the standard deviation. I hope now the idea is getting clear. Is it clear, Prananda?
Yes, yes.
yes.
Any other doubt in regarding? Now, mostly all of us have heard these terms here and there, and you can easily calculate with Excel. That is not the major issue here. How to use that? How to use the mean? What means is telling me? What is the median is telling me? What is the mode is telling me? Yes, that understanding you should have. Calculating this value is now computers everyone having, calculator everyone having, so that is not a big deal. That's why we are not focused on the formula and how to calculate that part we are not going into. We have directly introduced the Excel formula. But what important is that what is the interpretation? Like standard deviation is 6,000 means what? Means that whether that mean is having more values, so some people are less or not. That is the interpretation part we need to do. Then only descriptive statistic is useful for us. So now whenever I'm modeling this data or I'm something inferring from this data, I can have the better understanding that, oh, this is my data set. It has minimum 1000, maximum 90,000. It has mean around 17.5 thousand. It has mode to 15,000, and again it has the median on 15,000. In that case, it is the good sign that very less people are having more income. Majority of people are having low income in the category. So with that, today I think we will end our today's session. And one more thing which I was planned additionally to the measures of position, that is not much important. You can study, but we will next session we will give just brief introduction to the what is the quarter, what is quartile range, what is percentage, percentile. That is the part. So there you can check that how much data is falling below one. Like what 20%, 25% of people are having income from 10,000, 15,000, and such other interpretations can be done with quartiles and percentiles. Okay, so next session we will start with the probability. That is the main part of the core of the one of the importance theorem from the statistics, because we will directly into that, and we will go into the deeper part of that. Okay, so thanks a lot for attending the session. I will just share some reading materials I already shared, so that it will give just read 2 to 3 pages, so that you will get the clear understanding of what is the mean, mode, median, and it will reinforce you the its usage. Okay, thank you so much for all of you your participation.
Yeah, thank you.
Yes.
Thank you so much.
Thank you, Bhaiya. Thank you, Bhaiya.